Okay, this is an AutoCAD drawing. It's a plotting drawing. That is, we're going to be plotting graphs, and the subject of our analysis here is this little crank slider mechanism. So this is an internal combustion engine. We refer to it as a crank slider mechanism in engineering because you've got a crank going around in a circle, and then you've got this piston sliding up and down. Now, if we were going to design this thing, we need some more information, like, well, lots of things, but one thing we might want to have is velocity, and another thing is acceleration, right? Like, if we had velocity, for example, we could calculate the amount of air that's going in and out of this thing and how fast it's going, and that's useful for figuring out how much power the engine is going to generate. If we had acceleration, then there's something called Newton's second law, F equals ma. So if you had acceleration and mass, you could figure out forces, and that's useful for designing how strong you want the parts need to be. Like, okay, it's useful for figuring out the stresses on parts. Okay, so this kind of analysis was typically done in the past with so-called classical methods or continuous math, and here's a little analysis I presented for you. Now this is a pretty simple mechanism, and the math is already not, it's not too difficult, but for any real-life mechanism, the math is going to be much more than you typically want to deal with. So what we're going to do is we're going to plot the thing. So that's called a discrete method, and what we're going to generate is a plot that looks like this. So this is kind of what I want you to do and turn in, is just this plot right here, and I'll show you how to do that. And what I've done is I've labeled all the numbers on here. You don't need to label the numbers, that's a lot of work. I mean, you can if you want, but it's fine if you just get these curves. So what are we looking at here? So the piston's going up and down, okay, and it stops at the top, right, and stops at the bottom, and it's going pretty fast in the middle here, and it's it goes to the top, and then it changes direction pretty quickly at the top, and then at the bottom it's a little bit more gentle when it changes directions, and you can see that in the curves. So here's the top curve is the distance curve, and so the piston's at the bottom. I hope you can see my cursor here. The piston's at the bottom, and here are the pistons at the top, and back down to the bottom. And then the velocity curve, you can see the velocity curve peaks in the middle of the stroke, right? So when the piston's halfway up, that's when it's going the fastest. Likewise, when the piston's halfway down, that's when it's moving the fastest down. And the acceleration curve, you can sort of see that the highest acceleration is in the middle here when the piston is at the top, and it looks that way in the animation. You can see the piston sort of getting yanked back down pretty quickly, so that shows up as a high acceleration here. And then at the bottom, the acceleration is more gentle. So also note that these are not exact sine waves. They're similar to sine waves, but not exactly. All right, so that's what we're going to do. Let's see, what else is there to talk about? I have several things posted. I have this GIF posted for you. You can take a look at that. I have this analysis here. This is just if you're curious about the kinds of engineering analysis that you might be doing if you go into this kind of field where you're analyzing moving machinery. And then this here, this is posted, this time study help. It will make more sense to you after you've seen the demo, right? So you might want to read the instructions, watch this demo I'm going to do, and then maybe come back and look at this thing here if you're still kind of confused on the method. All right, so I'm going to close this because it takes a little bit of CPU cycles. Let's just look at the assignment here. This was assignment 20. So go ahead and read this. And then watch me do it, and then read back, and back and forth as much as you need to. But let me kind of go through the basic idea here. So here I've drawn a crank slider in 3 different positions. I've drawn it at the top, about a little ways down, and then at the bottom. And I've got a little circle that represents the crank turning around, and then I've got a bigger circle, or just an arc, really, but it was a big circle that I trimmed down to an arc. And this big circle represents the connecting rod. Okay, so what I've done is I've located the top position of the piston in this drawing on the left, and on the right, with these same two circles, little circle for the crank and the big circle for the connecting rod, I've located the piston at the bottom. Now in the middle drawing, I've located the piston at just some arbitrary location down. So the piston's traveling along the center line, and then where the center line intersects the big circle, that's how you locate the piston at that point in its travel. All right? So we need to do that for the entire stroke, right? The entire path. And that looks like this. So the circle in the middle here is the crank, and all of these big circles around here are the connecting rod. And right in here is information on the location of the piston at every 5 degrees, right? Because I've laid out these circles in here. These are laid out at 5 degrees. So it's like the crank turning at a constant speed. And I've laid out its position at every 5 degrees of its rotation. All right? And then you draw these big circles here at the intersections, at these little intersections of the red and black lines. You draw big circles. Then you come back in here and you draw a bunch of little lines. And then you use those lines and a bunch of tricks I'm going to show you that are in the instructions to generate this curve. All right? So read the instructions, look at all this stuff, and watch this video, and hopefully everything will go well for you. I'm going to move this off to the side. Let's start AutoCAD. I'm not real good at editing videos, so there's going to be parts in this video where I'm just drawing and not talking. Of course, if you don't listen to the whole thing, you might miss something. But anyway, sorry about that. Okay, look, here's this new, right? I'm going to click new, and then on my desktop, I've downloaded this A size inches thing. So I'm going to open that up. I'm going to delete a couple of lines here because I don't really need them. All right, let's get started. So I'm going to draw a line, matter right there. And with F8 ortho, you know, just draw it up like that. Then stick a 2-inch radius circle right here. Okay, then I'm gonna delete this whole. You know what? Let's move this. I just wanted it on the grid there. Okay, that's pretty good, I think. So now draw a line like this, and I need quadrant snap on here. Draw a line to this bottom quadrant. Okay, then pick that line and do an array polar. And here we want 37 items at 5 degrees. That's what we want right there. Okay, great. Then draw a circle at this end point here at 6.5. That's the length of the connecting rod. Draw that. Now what we want is a circle at every one of these endpoints. So really the easiest way to do that is just do an array polar about this center. Just do the same thing. Just do 37 of these guys at 5 degrees. That's what we want right there. All right, do that. Then get in here. I want to do this in red so that you can see what I'm doing. I'm going to do 0.3 fat lines so that you can see. Now you want to set up your snaps. You just want intersection. That's it. Intersection snap. That's all you want. Turn off ortho. You're going to want to, and turn off grid snap. You're going to want to be real careful with these ortho, grid snap, and object snap in this assignment. So now get in here and start drawing lines. So I like to kind of go off to the right and then move in on it from the right until I see my intersection snap, but whatever. Just draw all these guys like that. I don't know how to pan. I never pan. I only zoom in and out, and I know that can make people dizzy. I'm okay with it because I'm driving, but it'll make you car sick with these zooms in and out. Clickety clickety click. Draw all of these dudes. Okay, so what these red lines, and this is a bunch of little red lines, right? A bunch of little line segments. What they represent is the piston at every 5 degrees of the crank rotation. So select these guys and do a copy. Turn on ortho, F8, and grid, and copy them over here somewhere on a major grid line. Right there is good. And we just checked that I got a major grid line. Yeah, that's good. Okay, then take these guys and do an array rectangular. We want exactly 72, but you know, extra doesn't hurt, so we'll do 80. 80 columns, one row, and I want 0.25 inch. That's what I want right there. Enter. Okay. Then I just want to connect the dots. So we're plotting a curve discretely. This is the way they used to do these kinds of things before they had computers. You would just plot it with a pencil. And even if you were using a computer now or writing a program now, you would be programmatically or conceptually sort of doing the same thing. We call that discrete methods. Computer methods are called discrete methods, and they plotting with paper is a discrete kind of a method. So we want endpoint, just endpoint, right? And just start. So you turn off grid snap, turn off ortho, just have endpoint object snap, right? So you can move your cursor kind of freely, and then just start doing this thing. Grab the end of this. Now what you want to do is get in here and very carefully slide it up until you get to the next snap. Okay, see these boxes to enter numbers where it says 4.48 and specify next point? That's called dynamic input. So make sure you have your dynamic input check thing, and if you do, it'll give you this box right here. Turn that off. All right, now we can get in here with a little bit. You see how right there is what I want. Okay, then go over here. I want not that one, but where is it? That one. That's the next endpoint, because these are little lines in here. These red lines are it's not one line, it's a bunch of lines. There. And then like that. And as these get further apart, it gets a little bit easier. There. Okay, just draw all of these endpoints and kind of look at the curve to see if it's, you know, what you expect. That. Okay, then they're going to start to get closer together now. I'm sort of anticipating that with my, oop, what happened there? I don't like that. I don't know. I'm not sure what's going on there. I think I messed up. Let's see. I don't know what happened there. I'm just going to press on. Could fix it, but I don't want to. Okay, now here you're starting to get close to the top, so I'm looking for the correct little green box. There you go, that's that. Now it's going to be the same on the other way down, so we could just grab all of these guys here and do a mirror about 2 points on this line. That's it. Oops, dropped it. Mirror just 2 points on that line. Okay, that's our distance curve right there, right? Okay, now we want to do the velocity curve. So velocity is the change in distance, right? So we happen to have that information in here already. If I take this rectangular array and explode it, okay, then this line right here, that's the change in distance for this interval, and change in distance is velocity. So that this little line represents the velocity. The line right below the curve is the velocity for that interval. So pick those, right? This is the velocity for this interval. There's the velocity for that interval, that one. Each one of the, oh, that's messed up. I'm going to just keep it. Each one of these lines right below the green curve are the velocity lines. They represent how much the change in distance, which is the velocity. So select all of these guys. Okay. You know, you can turn on closed captioned on YouTube. You can also watch these videos at up to double speed. Do what you need to do. And this guy, the little guy. That's it. So that's all the velocity things. So copy those. I want ortho and grid snap. I'm just picking a point on the grid and copy these guys down to there. Okay, let me zoom in here, and yeah, it looks like I got it on the grid. Okay, that's all right. Yeah, okay, now let's go back to white lines, and I'm going to draw the axis, right? The time axis, the x-axis. Okay, then what we need to do, and this is, excuse me, this is kind of tedious, but we need to take each one of these little lines and align them, move them down basically with the x-axis. So I'm going to do a move command, pick this guy, enter. Okay, I got to play with my snap, so I'm going to turn off grid snap. Ortho's good. I just want, on my snaps, I just want endpoint and perpendicular. Okay, endpoint and perpendicular. Move this guy from the end point to perpendicular, right? And the next guy, enter to repeat the move command, end point to perpendicular, like that. We get in here, there, right there. Okay, so this guy, move it from here to here. This guy, move it from here to here. And like that, and just continue all of these guys. Tedious, but the good thing about this lab, you'll be really good at moving things. It's tedious, but you know, the only way to get faster at stuff is just to do it. So I'm pressing the enter button with my thumb. Okay, now these are getting kind of out of the way. I'm going to grab the whole set, repeat, enter to repeat the move command, just move them down like that so I can zoom in a little bit better. All right, this guy, move. This guy, I press the enter key with my thumb. The one on the numpad by my mouse. See, this is where if I knew how to edit videos, I would speed it up for you, but I haven't figured out how to do that yet. But if we're all going to be locked up for COVID-19 for forever, I guess I'll have to figure that out. Anyway, move these guys. I'm moving them with ortho right now using the grid because I want them straight up and down. I don't want to move them off the appropriate grid lines. Okay, as they get in here smaller, it's a little bit harder to, you have to do a little bit more zooming. Endpoint, that, okay? So that's the velocity data. It's too tiny, so we need to scale it up. Unfortunately, AutoCAD doesn't have a one-dimensional scale command, so the only way I've been able to figure out how to do this is grab all of them and make a block. So type block. Okay, where it says base point, make sure you have specify on screen checked. V is the name for velocity. Say okay. So I made that a block. Now I can delete all of this stuff and then do insert. Okay, name is V. Okay, here on scale you can, for 10 you can type in, I'm sorry, for Y you can type in 10. Okay, that'll scale just in the Y dimension, the Y axis only. Say okay, and then specify the same point you used for the when you made the block, which I used this point here at the end of the axis. And it's not there. Okay, I don't know what's happening here. Let me control Z, control Z, control Z, control Z, control Z. That's a block. Let me just do an insert. I think I messed up my insertion point. So let's do 10 on the scale. Yeah, that's what happened. Okay, yeah, it's way down there. Oh, shoot. I messed up my insertion point, but it's fine. I can still put it on the end point. All right. I'll delete this block that I made before, and I'll grab this thing and do a move command. We'll move it from the end point of that, move it perpendicular to that. All right, fixed. That's our velocity data. So let's take that, and we need to mirror it twice, which turns out to be the same as a rotation. So do a rotate about this point, and I have ortho on, so it's doing these 90-degree things. So right there, Control Z, and say this guy, rotate, face point, this end point. Okay, I forgot to click copy. Click copy, 90, there we go. Then there's a little weirdness with this method. It's off by 1 cycle, so you need to move it. And I'm just going to use, let's see, F9 turns the grid back on. I'm just going to use 2 points on the grid to move this guy over 1 cycle, like that. Right, that's that. So back to green, back to heavy, turn on just endpoint snap. I'm going to turn off ortho and turn off grid snap, and then I'm going to come in here and start drawing lines. So endpoint, 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 endpoint. Just like that. So I have grid snap off, ortho off, and I have this dynamic input off to just clean the screen up. And I only have endpoint snap on, just endpoint snap. Oops. I'm on a roll, so I'm just going to come back and fix that later. We'll fix this now. Stretch this guy up to that endpoint. Take this thing, stretch this guy up to that, like that. Okay, then I need to mirror these lines. So pick them, get them all selected, and need to mirror them twice, or really rotate them about this. Let's see, yeah, shoot. I want this intersection right here. I want that intersection, and turn on F8 ortho to get it around like that, and quick copy that. That's it. That's our velocity curve. Okay, time to do acceleration. So acceleration, okay, for velocity we had these little lines on the distance curve which represent velocity. So we don't have those lines on the velocity curve. It's because we're looking for acceleration, right? And acceleration is the change in velocity. So we need to go get the change in velocity. So I'm going to use yellow lines and start drawing this thing. So turn on snapwise, intersection and perp. Right, intersection and perp only. Turn off ortho, I think. You know what? I want. I think that's okay. So start drawing lines. Perp, int, perp, int, perp, int. Like that. Just start drawing this zigzag business. Really, we want what we're trying to get is the vertical yellow lines. Those are the change in velocity for each interval, and the change in velocity is what we call the acceleration. Oops. I slipped, so right there. Okay, it's a little bit ambiguous on what to do here. Wait, this one's not right. We'll fix it later. Don't overthink it. Look, we'll come back over here, start another line like this, and then perp, int, perp, int, perp, int, perp, perp, int. Intersection perp, indicular. I'm getting perps by accident, you see. You got to be careful that you're getting. It might be better to use endpoint and perp, maybe. Yeah. No, that's not any better. You just got to be careful. See right there, it wants to do perp, but I don't want perp. I want endpoint. Right here, it's fighting me a little bit. Yeah, like that. Okay. So these little yellow lines here, they represent the acceleration, because they're the change in the velocity, right? For each interval. They're the change in velocity. All right, select them. So okay, I need one right here. Yeah. That guy, that guy, that guy, that guy. All right, pick these guys. There's really no way to get these other than just a lot of mouse work. Sorry, my mouse is. Okay, I need another line, but I don't want to lose this selection. So I got those guys, then copy. And with grid point on and ortho on, copy them down. Oh no. What happened? Oh, it's fine. I just selected. Okay, great. I had the red selected by accident. I didn't want that, but there it is. It's there's one line I missed, so I'm going to go back and draw a line in here. All right, and take this guy and copy it from. Let's use this endpoint because we've got that guy down here. There. It turns out that'll be okay because we're going to move him anyway. So now go back to white and draw your axis. So draw axis right here. And that's the axis. That's the right location for the axis. Draw the axis. There it is. Okay, then more tedium. Go turn off grid snap, turn off. We just want endpoint perp. I'm going to turn off ortho. I'm not sure if I need to turn it off. I'm going to turn it off. And then, so pick this, move, endpoint, perp. This thing, move, endpoint, perp. This thing, move, endpoint, perp, like that. Okay. Do this. I'm going to grab these guys and just move them down closer, so with ortho on, just so I don't have to do as much zooming. So this thing, move, perp. This is really tedious, but like I said, it is good practice for hey, we got it. So that all those guys, that's the change in velocity, which we call acceleration. These little yellow lines, which came from the velocity plot. All right, now they're too small, so make a block. So grab all of these guys, type block. Okay, make sure the specify on screen is selected. I'm going to name this guy A for acceleration. Say OK, and then it's prompting me for the base point. That's where I messed up last time. I want to make sure I got this end point here. All right. Okay, so I can delete it, and then I can type insert. And A is up there. I could also do V, but I don't want V. But anyway, you could change what you're inserting by typing a new name. Anyway, A, I want 10. I want to scale it up 10 in the Y dimension. Say OK, click my endpoint. There we go. All right, so the method has some flaws, as you can see here. We'll have to fix them. So we need to explode this thing. All right, then this thing is too small, so we're gonna stretch it up with ortho. I'm just gonna eyeball it about there. Okay, now it turns out that this part of the stuff is upside down. It's just kind of the way the method works. So we'll grab this stuff and mirror it. Okay, just pick 2 points on this axis. Delete the source objects, yes. And you can see that there's some weirdness going on in here. I'm gonna use a green line, heavy. Let's draw a line. Let me turn off snap. See, that's the way it's right there, is the way it should be. So just sort of ignore what's happening there. There's some problem with the method that I haven't actually figured out, but and this last guy, there's no way that it drops down like that. So once again, it's the method. I'm just gonna go perp to this guy. Snap override. We'll go perp to this guy right there. Okay. Then yeah, grab all of these lines and these lines and this one and mirror them about. I want intersection. This, mirror them about, and with the intersection snap and F8 ortho on that. Dropped it one more time. That stuff, that and that. Do a mirror about this intersection there. Delete, erase source objects. No. Okay, that was it. And line, connect the dots here. Yeah. That's it. That's velocity, or rather distance up here, velocity right there, acceleration right there. And just, you know, capture the screen. You know, if you guys want to save toner, let's see, stop. If you want to save color, you can right click on the screen and go to options and go to the display tab, right? And then colors tab, you can click this and do white, apply and close, and then it does this, it inverts the screen colors. And then when you do the Windows snipping tool, right, you can you know, you can capture the screen like this, and you know, copy this, copy it into the clipboard, and then go to Word, and then you can paste this in there, and you can save it as a PDF. Okay, that was it. Don't worry about all the numbers on there. Now you could, you know, in real life, whatever, so to speak, you could keep track of these numbers. You know, this is really just about learning AutoCAD. It's not so important to keep track of these numbers. There are more sophisticated tools that would do this kind of analysis. This is what you'd really use. In the old days, you would plot things, but now we have more analysis tools. All right, thanks.